This is section 2.3, part B, the remainder and factor theorem. Synthetic division is a shortcut for dividing a polynomial by a linear factor of the form x minus c. We can only use synthetic division when we can get what we're trying to divide by in the form of x minus c. If we cannot get it into that form, you will have to divide using long division. So if we take a look, we are dividing in the form of x minus c. So the first thing we need to do is we need to get the x value by itself. Right now we have x minus 3 is equal to 0. You want to get the x by itself first, so we're going to add 3 to both sides. And we get an x value of 3. So this is what we're going to put in the top left corner of our synthetic division. Now you need to check what you are dividing and make sure that the exponents are in descending order and that none of the exponents are skipped. We go third, second, first, and then no exponent, which is in the correct order. If any of the exponents are missing, you will need to put in a 0 to hold its place. But since none of them are missing, we're just going to write down the coefficients. Now we always start by bringing the first value straight down. You are then going to multiply whatever's in your corner with the number that you brought down. So 3 times 6 gives us 18. And whatever their product is, you write under the next value. You add straight down. So negative 25 plus 18 gives us a negative 7. Again, once you have a value underneath the line, you multiply what's in the corner by that value. Positive 3 times a negative 7 is going to give us a negative 21. Again, we add straight down, so 18 plus a negative 21, or 18 minus 21, gives us a negative 3. And 3 times that negative 3 is going to give us a negative 9. When we add those down, 9 plus negative 9 gives us 0. Now we are dividing by an x minus c, so you are dividing by an x, so it will reduce your largest exponent in our answer. In the problem, our largest exponent was 3, so our answer, the largest exponent, will be to the second power. So our quotient is going to be 6x squared minus 7x minus 3. Since we have a 0 at the end, it means there is no remainder. But if you would have had a remainder, you would add it on. And let's say this was 2, we would have had plus 2 over x minus 3, because x minus 3 is what you were dividing by. But since there is no remainder, this is our answer. A depressed polynomial is what we just found. It is the quotient when a polynomial is divided by one of its binomial factors of the form x minus c. So the answer down here is a depressed polynomial. It's the polynomial reduced by one of its factors of the form x minus c. If we look at this example, remember first you have to make sure you're dividing in the form of x minus c. If we look, this is ax plus c, so this is not in the correct form. It can be a positive value, it could be x plus 1, but since there is a 4 in front of it, we do have to get rid of that 4 first. So before we can start, we actually have to divide everything by a 4 to get the x by itself. If we divide on the left side first, this is going to leave us with now on the right side, what we're going to be dividing by is going to be x plus 1/4. Remember, to be able to do synthetic division, we want to get the x part by itself. So if we set this equal to 0 and then get the x by itself, we are going to be using negative 1/4 in our synthetic division. You use the coefficients from your polynomial, and then we are going to bring that first value straight down, and then we are going to multiply. 2 times negative 1/4 is going to give us negative 2/4. 38/4 minus 2/4 is 36/4, and 36/4 is equivalent to 9. If we multiply now, we have 9 times negative 1/4. That's going to give us a negative 9/4. 5/4 minus 9/4 will give us a negative 4/4, which if we reduce that will give us negative 1. Negative 1 times negative 1/4 is going to give us a positive 1/4. If we add those straight down, that'll give us a value of 1. And 1 times negative 1/4 will give us a negative 1/4. 3/4 minus 1/4 is 1/2, or 0.5. Now remember, it's going to have 1 less on my largest exponent. Since this starts out as 2x to the 4th, we are going to be left with 2x to the 3rd after we divide. So we'll be left with a quotient of 2x to the 3rd plus 9x squared minus x plus 1. But we do have a remainder this time, so it's going to be plus 0.5 over what we were dividing by, which is the x plus 1/4. Again, to get this into the correct form, we are going to have to divide to get the x by itself. So we would divide everything in this problem by 3. If you noticed, I added in a 0x squared. There is no x squared, so we do have to add it into our problem. And then after we have x plus 2/3, we do need to get the x part by itself. So x is going to equal negative 2/3, and this is what we're going to use with our synthetic division. So across the top, we have our negative 2/3, and our coefficient from our polynomial is 3, 0, negative 1/3, and negative 1. Remember, we bring that first term straight down. 3 times negative 2/3 is going to give us negative 6/3. And 0 plus negative 6/3 is just negative 6/3. But if we reduce that, that's going to be negative 2. Negative 2 times negative 2/3 is going to give us a positive 4/3. And negative 1/3 plus 4/3 will give us 3/3, which we can reduce to be 1. 1 times negative 2/3 will give us negative 2/3. And if we add that down, 1 is equivalent to 3/3. So negative 3 plus negative 2 gives us a negative 5/3. We started with an x to the 3rd, so after we divide, we're going to be left with x to the 2nd. Once again, we are going to have a remainder, and we were dividing by this x plus 2, x plus 2/3. So our 5/3 will be over the x plus 2/3. Now you can also use the remainder theorem to evaluate a polynomial of the form f of x for any x value of c. We can do this by dividing f of x by x minus c, and whatever the remainder is, that's actually the value of f of c. So what we can do is if we have an x value, we can use synthetic division, and whatever you get as the remainder from your synthetic division is the actual answer for your problem. Synthetic substitution is the method of using that synthetic division to evaluate a function, which is what we were just talking about. So if you want to find the value of x is equal to c, you would use synthetic substitution. For this example, we know that the number of tickets sold during the Northside High School football season can be modeled with the following polynomial, where x is the number of games that have been played. Using the remainder theorem, we need to find the number of tickets that are sold in the 12th game. So our x value is going to be 12, so that's what we're going to use with our synthetic division. We use our coefficients, so we have 1, negative 12, 48, and 74. Remember, we bring that first term straight down. 12 times 1 gives us 12. Negative 12 plus 12 is going to give us 0. 12 times 0 is 0. If we bring that straight down, we're going to have 48. 12 times 48 is going to give us 576. If we add 74 and 576, that will give us a remainder of 650. So that means there are 650 tickets that were sold for the 12th game. The factor theorem says a polynomial f of x has a factor of x minus c if and only if f of c is equal to 0. So what this means is if I try to divide a polynomial by a binomial of the form x is equal to x minus c, if we do not get a remainder, then you know that that was actually a factor of your polynomial. So we are going to use this theorem to determine if x minus c is a factor of this polynomial and if x plus 3 is a factor of this polynomial. And then we're going to write this in the factored form when we're done. So if I'm checking x minus 1, remember you put it equal to 0 and get the x by itself. So we're going to check x is equal to 1 first. So if we set up our synthetic division, make sure again you check to make sure you didn't skip any exponents. They are all there, so we can go ahead and solve. So we're going to get 4 here. 1 times 4 is 4. If we add down, we're going to get 25. 1 times 25 is 25. If we add that down, we're going to get 50. 1 times 50 is 50. If we add down, we're going to get 45. And 1 times 45 is 45. If we add down, we get 48. So we do have a remainder in this case. Since there is a remainder, we know x minus 1 is not a factor of this polynomial. We can do the exact same thing with our x plus 3. Remember, first we need to get the x by itself, so we're going to use negative 3. Now the nice thing with these, if the first one works, you actually don't have to go back and try the original problem again. You can divide the second one by the quotient that is left after the first synthetic division, and that'll actually help you break down and factor your problem even more if both of them work. But since x minus 1 did not work, we do have to go back to the original problem. Negative 3 times 4 gives us negative 12. When we add down, we get 9. Negative 3 times 9 is negative 27. If we add down, that's going to give us negative 2. Negative 3 times negative 2 gives us 6. When we add down, we get 1. Negative 3 times 1 is negative 3, so this does give us 0. So this one actually is a factor. So we are left with, we divided by x plus 3, and we're left with the quotient, which is 4x cubed plus 9x squared minus 2x plus 1. Now, we don't know any other methods right now to help us fact this any farther. Later on in this chapter, we will be learning other methods, but for right now, this would be the factored form of our equation. Let's try one more of these. We're first going to try x plus 4. If we get the x by itself, we're going to have x is equal to negative 4. Negative 4 times 2 is going to give us a negative 8. When we add down, that's going to give us a negative 9. Negative 4 times negative 9 is a positive 36. If we add down, we get negative 5. Negative 4 times negative 5 is a positive 20. When we add down, we get 0. So this is a factor. Since it's a factor, when we check x is 5, we do not have to go back to the original. We can take our quotient up to use for the second one. So when we check 5, we can check it against the quotient, because if it is a factor of the original, it would still be a factor of the quotient. 5 times 2 gives us 10. If we add down, we get 1. 5 times 1 is 5. If we add down, we get 0. So this is also a factor. So if we write this in factored form, we already have x plus 4 and x minus 5, because we know they went into it. This was x to the third. We divided once, so this would have ended up x to the second. So if this is x to the second, we divide once more. This is just going to be 2x. So our polynomial in factored form is x plus 4 times x minus 5 times 2x plus 1.